Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I solved question number 3 related with exercise number 5.3 relevant with the topic integration by parts. In today's video, I am going to solve the next question number 4 related with the same topic integration by parts. But in this question, there are total 3 parts. In this question, we will integrate the function first by the method of substitution, and after this we will apply integration by parts. So this exercise number 5.3 is related with chapter number 5 integration FSC part 2 mathematics KPK board. So let's move toward exercise 5.3 mathematics FSC part 2 integration chapter number 5. Question number 4 tells that integrate the following integrals by the parts integration through the appropriate substitution. So over here we will do some substitution, and after this we will integrate the two functions by using integration by parts. So over here if we put let's suppose ln of x is equal to t. So differentiate both sides with respect to x, so it become dt by dx, and on this side derivative of ln of x with respect to x is 1 over x. Now shift dx on the right hand side, it become dt is equal to dx divided by x. So putting these two values in the given integral, so our new integral will be generated in the form of differential dt. So ln x we suppose t, so it become t into sine time of ln of x is t, and dx divided by x is actually dt. So over here we have two functions. First is arithmetic function and sine t is a trigonometric function. So again using Euler's rule, so arithmetic function comes first and sine t is trigonometric function which comes after the arithmetic function. So the first function will be actually t and the second function will be represented as a sine t. So over here we will use the formula that let's suppose u is equal to t and our dv by dt is actually equal to sine t. Now we have the formula for integration by parts, that is actually equal to uv minus integral of v du. So over here our u is equal to t, so putting t over here. Now we need the value of v, so from over here we can get the value of v easily. So over here dv by dt is equal to sine t. So shift dt on the right hand side, it become dv is equal to sine t dt. Integrate both sides. So on this side we left with v is equal to, and on this side sine t integration is negative cos of t. So the value of v is equal to minus cos of t, so put over here minus cos of t, and after this negative sign integral of v, our v is negative cos of t and du. So our du from over here differentiate both sides with respect to t, so it become du is equal to dt. So putting du is equal to dt over here, it become dt, so it become minus t cos of t, and minus minus will give us plus, so an integral of cos of t is actually sine of t. So this is not our required answer because the original variable is actually x. So replace again t with ln of x. So it become minus time of ln of x into cos of t. So cos of t is actually ln of x. So it become cos of ln of x and plus sine time of t. So our t is ln of x. So this is actually the required and desired answer, minus ln of x cos of ln x plus sine. Over here we replace t with ln x, it becomes sine into ln x plus constant of integration. This is the answer. Now move to the next part number b, integral of sine 2x into ln of cos x dx. Integrate this function by the method of substitution, and after this apply integration by parts. So you know that sine 2x is actually equal to 2 sine x cos x. So put over here sine 2x replaced with 2 sine x cos of x and ln of cos of x and whole dx. Now over here it 2 sine x cos x. So over here we have cos x derivative is present, which is actually sine x. So we will, let's suppose take sine cos x is equal to variable t. Let's suppose t is equal to cos x. So derivative both sides with respect to x, so it will give us dt is equal to cos x derivative is negative sine x and dx. So putting these two values in the integral, it become integral of 2 into sine x and dx. So this is actually equal to negative dt. It become shift minus on this side, it become negative dt is equal to sine x dx. So minus time of dt, and over here we left with cos x ln cos x. So cos x is actually t, so 2 into t, ln of cos of x is actually t. So it become minus 2 will comes out outside the integral, so it become minus 2 t ln t dt, t ln of t dt. So over here we use the integration by part. This is first function, and now we know that Euler rule. So in Euler rule, logarithmic function comes first and arithmetic function comes after. So over here logarithmic function will be considered as a first and t will be considered as a second. So using integration by part of first function, integral of the second function t dt minus time of integral of derivative of the first function, which is actually ln of t, and integral of the second function, which is t dt and whole dt. So after this it become minus 2 into ln of t. Integral of t is t square by 2, and after this minus time of integral of derivative of ln of t is 1 over t into integral of t is t square divided by 2, and this dt will come down as it is. So it become minus 2 will cancel out over here. Now this minus 2 will come down as it is. Now first we simplify it, so it become t square by 2 into ln of t, and after this minus 1 by 2 will come out outside the integral. We left with t square by t will give us just t dt. So it become minus 2 into t square by 2 ln of t. It become minus 1 over 2. T integration is t square by 2. So this 2 cancel out with 2, we left with minus t square ln of t, and over here 2 cancel out with 2, we left with just 1, and minus into minus will give us plus t square by 2, plus t square by 2. So after this replace t with cos of x, so it become minus cos square x into ln of cos of x, and it become plus cos square x and divided by 2. So this is actually the required and desired answer. Now move to the last part of today's lecture, and the last part of question number 4, part number C. Integral of e power 2x into sine e power x dx. Integrate this function by substitution and integration by parts. So we can write the integral in the form of integral of e power 2x can be written as e power x multiply e power x. Because the bases are same, again the power will be added, it gives us e power 2x. And after this sine e power x dx. Now rearranging this integral, so it become multiply e power x with dx on the right hand side, so it become e power x dx, and write e power x and sine e power x combine. So now let's suppose I assumed t is equal to, let's suppose t is equal to e power x. So our dt will be e power x dx. Putting these values in the integral, it become integral of e power x, we suppose t, so it become t, into sine into e power x is t, and e power x dx is actually dt. Now using Euler rule, so one is arithmetic and another is trigonometric. So arithmetic will be considered as a first and trigonometric will be considered as a second function. So using the formula, first function integral of the second minus integral derivative of the first function and integral of the second function and dt. So first function is actually t, so put over here t. Integral of second is sine t, so sine t dt minus time of integral of derivative of the first function. So first function is t and integral of the second function. So second function is actually sine t dt and whole dt. So it become t into sine t integration is negative cos of t, because if we differentiate negative cos t, it will give us sine t. Minus time of integral of derivative of t is 1, and sine t integration is negative cos of t and dt. So it become minus t cos of t, and minus into minus will give us plus. Integral of cos of t is actually sine t and plus constant of integration. Now replace t with e power x, so it become minus e power x into cos of e power x and plus sine into e power x and plus constant of integration. This is actually the required and desired answer. So with this question I finish my lecture. Inshallah in the next video I will start exercise number 5.4 related with the same chapter number 5, integration. So thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification and a interesting problem related with mathematics. Thank you.